Welcome to my algebra class. We're on chapter 10, section 4, and another section which is called union intersection. We're going to explain the union intersection section first. If I'm finding the union of two sets of numbers, that's joining the two sets together without any repetition. And the symbol for union is a right side of U. Whereas intersection is finding what two sets share or have in common. And the symbol is an upside down U. And that would be intersection. So here we have three sets. A, which contains 1, 2, 3, 4, 5, B, 2, 4, and 6, and C, 7, and 8. So if I take set A union set B, I want all the numbers that are in both of them without repetition, and we keep them in numerical order. So 1, 2, 3, 4, 5 is in set A, and set B I can see 2 and 4 are also there, but I don't repeat them, but there's also a 6, so I put 6 down. So that would be A union B. A union C would be to take A and put it together with C, and I would have 1, 2, 3, 4, 5. That's set A. Set C contains none of those, but it does have 7 and 8, so I would add those in. The intersection of A and B is what numbers are in both. So I can see 2's in both and 4's in both. So the intersection would be the set containing 2, 4. A intersection C would be the empty set. That's the set that contains no numbers. It's also indicated by a slasher called the normal set. We use Venn diagrams, which are circles, to show relationships among sets. So if I wanted to show the relationship of A and B, I would draw two circles overlapping each other. So this would be set A, and this would be set B. And in the middle part, I would put what the intersection is, which is 2 and 4. And then the part that's not shared by B, I would put 1, 3, 5. And for B, it would be the 6 over here. If I wanted to show A intersection C, the two circles would be what we call disjoint. They would share. So this would be set A, and this would be set C. And notice I didn't overlap them because they share nothing. This has 7 and 8 in it. And it says 1, 2, 3, 4, 5. So we're going to be working with that, and then we're going to apply the idea of union and intersection to solving inequalities that we combine. So what we're going to be doing is having compound sentences as you do in English. And there are two types in math. Conjunctions, which are compound sentences connected by and disjunction, which are compound sentences connected by or. So this sentence here says -2 is less than x and x is less than 3. The word and indicates that both things must occur, so that's an intersection. We have to find all the numbers where -2 is less than x and all the numbers where x is less than 3. And we can put those into a simple sentence like this. All the and sentences can be rewritten like this, and this is the method I prefer because it's the graphic setup. So x is greater than -2 and less than 3 are all the numbers that work. And if I want to graph that, I draw the number line, and putting arrows at both ends. Here's -2, here's 3. We don't have the bars, so it's an open circle at -2, open circle at 3, and it's everything in between. So this is what we call the tween problem. And the other type of compound sentence connected by or, here's a example here. I would solve this, just as I've always done, add 1 to both sides. So I get 2w is less than 4, divide by 2. And we get w is less than 2, or that word has to stay there. And then solving the second inequality, I would subtract w from both sides because I want to get w on one side. So that would be 2w is greater than or equal to 10. Divide by 2, and w is greater than or equal to 5. So in this case, with an or sentence, the numbers can be less than 2, or they can be greater than or equal to 5, which is actually finding the union. This was intersection. This is what they had in common. So graphing this, here's 2, and here's 5. I'm using this final answer to graph. X is less than 2 would be an open circle at 2, shaded to the left, solid arrow. And w is greater than or equal to 5 would be a closed circle, shaded to the right, solid arrow. So notice the difference between the and the or inequalities. Okay, we're ready to start the assignment. So we're going to start with page 476, numbers 1 to 16 first. So head your paper, skip a line, the title. And we're doing number 2 on 476. We're referring to the diagram on the right side of your paper there in the book. And we're going to be finding the members that apply. I'm going to go ahead and put the diagram down and refer to it. So we have 3 circles. This is a Venn diagram. And we have set D and set E and set F. And in D, in this part that isn't shared with any other set, we have 1 and 2. In the intersection here with F, we have 5. In the intersection here, which is the part that intersects all 3 sets, we have a 6. 9 is here. That would be the intersection with D and E. There's a 0 here. And in this intersection with F, we have 7 and 8. And then finally, the 3 and the 4. So problem number 2, D intersection E would be what is shared by D and E. Here's D, here's E, and the intersection of D and E is right here. So it'd be 9 and 6. Maybe I'll use invisible ink on that one next time. Okay, so we have 9 and 6 as the intersection. And they should be written in numerical order, so we'll put 6 and 9. The next problem, number 4, Whoops, I did the wrong one, didn't I? Okay, well, let's start again. Number 2 is D union E. So that's putting the two sets together. So D union with E would be everything in D plus everything in E without repeating. That would give us 1, 2, whoops, we got 0 there too. 0, 1, 2, and we have 5, and there's 6, 7, 8, and there's a 9. So that would be the union of the two sets. E intersection F is what is shared between E and F, and that would be in this part right here. So that would be 6, 7, 8. And 6 is D union, and then parentheses E intersection F. Since we do grouping symbols first, we find E intersection F first. So E intersection F would be right here. So that gives us 6, 7, 8. And that's going to disappear here. So that's 6, 7, and 8. Union with D. And D is 1, 2, 5, 6, 9. So if I put those two together, my union would be 1, 2, 5, 6, 7, 8, 9. And number 8 is D union E union F. D union E would be all of these numbers here, all of these plus all of these. And we're going to union it with F, so that would be the entire set of numbers. So if we put them in numerical order, we would have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And problem 10, express 6, 7, 8, 9 in terms of D, E, and F. So we want to end up with D, E, with 6, 7, 8, and 9. Well, 6, 7, and 8 is the intersection of E and F. So if I said E intersection F, and 9 is the intersection is in the intersection of D and E. I gotta get 9. So if I said D intersection E, I would get the 9. And if I union them, then I wouldn't be repeating that 6. So that would give it to me right here. So 7, 8, 9 was in the intersection of E and F, and, excuse me, 6, 7, and 8 was in the intersection of E and F, and 9 was in the intersection of that one. So there's my problem. And problem number 12, it says specify the union intersection of the given sets. So number 12, I have -1, 0, 1. And I want the union and then the intersection. The union of those two sets would be to put them together. So the union equals -1, 0, 1, 2, 3. The intersection is what they share. And if we look at it, they share 0 and 1. So the intersection would be 0, 1. Problem number 14, the sets are 6 and 8, and 5, 6, 7, 8, and 9. The union of those two sets is putting them together in numerical order, which would give you 5, 6, 7, 8, and 9. And the intersection would be what they share. And we can see they both have a 6 and they both have an 8. So the intersection is 6 and 8. And number 16, the sets are -5, -4, -3. And the other one, -2, -1, and 0. So the union is to put them together without repeating. So that would be -5, -4, -3, -2, -1, and 0. And intersection would be what they share, and they share nothing, so we would put the null set, the 0 with a slash through it. And they said tell us if it's disjoint. And it is disjoint. That concludes the evens on that. Our next assignment is on page 480. These are the compound sentences 1 to 24. So problem number 2, draw the graph of each of these. 2 says r is greater than 3, or r is less than or equal to -2. So remember, this is like union. We just join them together on the same number line. So r is greater than 3 would be an open circle shaded to the right, solid arrow. R is less than or equal to -2, that would be closed because we have the bar. Shaded to the left, solid arrow at the end. Problem number 4, s is less than -2, or s is greater than or equal to 0. That's union. So we just put them together on the same number line. Here's -2 and 0. Make sure you put your numbers down correctly. We have an open circle at -2 since it says less than, all the numbers less than -2. Solid arrow at the end. Or all the numbers greater than or equal to 0. So closed circle at 0 is shaded to the right. The next set of problems, solve each open sentence, then graph the solution set if there is one. Problem number 6, we have -2 is less than y minus 2 is less than or equal to 1. This is a compound sentence connected by and. It's written in the short form. So to solve it, we just go ahead and get y by itself in the middle, and to do that we need to add 2, so we can get rid of the -2 here, but we have to do it everywhere to balance the inequality. So we add 2 in all places, and we end up with 0 is less than y is less than or equal to 3. So that's a compound sentence. It's a between problem. So y is greater than 0, and y is less than or equal to 3. That's how you read that. So we put the 0 down, the 3 down, open circle at 0, closed at 3. And it's all the numbers in between. Any number in between here will work. For example, 1 minus 2 is -1. That's greater than -2, but less than or equal to 1. Problem number 8, -6 is less than or equal to 3 plus r is less than 4. Another compound sentence connected by and, written in the short form. So to get r by itself in the middle, we have to subtract 3 from the 3 parts of this compound sentence. So we get negative 9 is less than or equal to r is less than 1. Since r is by itself and the inequalities are in the right direction, they're all pointing to the left, we can go ahead and graph it. So here's negative 9, here's 1. R are all the numbers between negative 9 and 1, including the negative 9. So we put a solid circle at negative 9, open at 1, shaded in between. Problem number 10, we have negative 2 is less than 2b minus 1 is less than or equal to 5. So we have a two-step problem in the middle. To get b by itself, we first undo the minus 1, so we add 1 to all three parts. And we get negative 1 is less than 2b is less than or equal to 6. Then to get rid of the 2, we divide each of the three parts of the compound sentence by 2. So we get negative 1/2 is less than b is less than or equal to 3. Everything's ready here to graph. So draw your number line. Put negative 1/2 here, since it's between 0 and negative 1, and 3 here. We put an open circle at negative 1/2 since it says less than, and a closed circle at 3, and it's all the numbers, b is between those numbers. Solid line. Problem number 12, negative 8 is less than 3n plus 7, and 3n plus 7 is less than or equal to 1. Again, a two-step problem. We undo the addition first to get the n by itself in the middle. So we subtract 7. We get negative 15 is less than 3n is less than or equal to negative 6. Now we got to get the 3 out of there, so we're going to divide everything by 3. So we get negative 5 is less than n is less than or equal to negative 2. Everything's ready to graph. We have n by itself in the middle, the less than signs. We need less than signs to graph it correctly. So it's negative 5 and negative 2. Open circle at negative 5, there's no bar. Closed at negative 2 because of the less than equal to. And it's all the numbers in between. Problem number 14. We have h plus 5 is less than or equal to negative 2, or, this is a union problem, h plus 5 is greater than or equal to 2. So solving the first inequality, we subtract 5 from both sides, and we get h is less than or equal to negative 7. Bring down the or. So remember what kind of problem we have. Subtract the 5 here from each side, and we get h is greater than or equal to 0. Okay, everything's ready to graph. So we put these two together, it's union, on the same number line. Here's negative 7, here's 0. The solution to this system of inequalities is everything less than negative 2, or this compound sentence, or equal to negative 7. So we shade it to the left. And h is greater than or equal to 0. So that would be a closed circle at 0 shaded to the right. Kind of look like eyeglasses. No, I won't do that. Number 16, we have 1 plus 2y is less than negative 9, or 1 plus 2y is greater than 9. Solving the first inequality, we subtract 1 from both sides. So now we have 2y is less than negative 10. Divide by 2, and y is less than negative 5. Bring down the or. Here we subtract 1 from both sides. We get 2y is greater than 8. Divide by 2, and we have y is greater than 4. Compound sentence connected by or. So we have two arrows going in opposite directions. Here's negative 5 is 4 It's less than, open circle, shaded to the left, solid arrow. Greater than, open circle, shaded to the right, solid arrow. Problem number 18, if 2d minus 5 is less than negative 7, or 7 is less than 2d minus 5. First inequality, add 5, and we get 2d is less than negative 2. Divide by 2, 2, d is less than negative 1. Bring down the word or. Here we add 5 to both sides to solve for d. So we get 12 is less than 2d. Divide by 2, and we have 6 is less than d. Now remember I said make sure it's ready to graph. This is not. You will need to turn it around so it's written according, add the variable first, so it's written accordingly to the way the graphing will happen. If 6 is less than d, then d is greater than 6. So we're ready to graph. We have a negative 1 here and a 6 here. This says d is less than negative 1, open circle, shaded to the left, solid arrow. Or d could be greater than 6, that's an open circle, shaded to the right, solid arrow. Section B, number 20, we're going to see the inequalities turn because we're going to be multiplying or dividing by negative numbers. So here we start out with a compound sentence connected by and, intersection ones in the short form, and we want to solve for x, so we're going to divide by negative 2. The minute I divide by negative 2, I have to turn the inequalities around, so it's going to be greater than or equal to now. So I get 4 is greater than or equal to x is greater than or equal to negative 3. Now this is not ready to graph, so when that happens and I get greater than, I have to turn it again so I can graph it. 4 is greater than or equal to x, and x is greater than or equal to negative 3. So that's the same as negative 3 is less than or equal to x, and x is less than or equal to 4. Basically, just make sure that the numbers are in the correct order of the number line, and you turn your inequalities again. So that's a double turn. So we have negative 3 and positive 4. And it's a closed circle at negative 3 and a closed circle at 4, shaded in between. And I could check that. For example, I could take zeros between those numbers. And if I take negative 2 times 0, I get 0. And negative 8 is less than 0, and 0 is less than 6, so it works. Number 22. We have negative 2 is less than 3 minus y is less than or equal to 1. Okay, we have a, get rid of the 3 first, so we're going to subtract 3 first from all 3 parts. So we get negative 5 is less than negative y is less than or equal to negative 2. Okay, this is a negative y, so I got to make it positive, so I'm going to multiply everything by negative 1. So that becomes 5. This turns, because I'm multiplying by negative 1, y greater than or equal to positive 2. Now looking at this, the 5 and the 2 are not in the correct order to graph. So I have to turn it around, change the inequality, and remember the 2, y is greater than or equal to 2, therefore 2 is less than or equal to y. And 5 is greater than y, so y is less than 5. Make sure you have the right inequalities as you turn it around. And graphing it, we have 2 and 5, it's correct order. Closed circle at 2, because 2 is less than or equal to y. Open circle at 5, because y is less than 5, shaded in between. And you can pick a number and check it, and it works. And problem number 24. We have negative 7 is less than negative 1 minus negative 3x is less than or equal to 8. So we got to get x in the middle. First add 1 to all 3 parts. And we get negative 6 is less than negative 3x is less than or equal to 9. Now we have to get x by itself, so we have to divide by -3, which is going to turn the inequalities. We'll do that in the next line. So this is +2. This becomes greater than x, as the 3's go out, greater than or equal to -3. Looking at the numbers, those are not the correct order to graph. So I'm going to move the -3 over here. Keep the right inequality, it'll be less than or equal to. X is greater than or equal to -3, therefore it's less than or equal to. -3 is less than or equal to x. 2 is greater than x, therefore x is less than 2. And then graphing it, we put an closed circle at -3 since it's less than or equal to x. Open circle at 2, shaded in between. That concludes the evens. Be sure you check the back of the book for the answers to the odds.